Okay, it's important in doing calculations having to do with solutions to really memorize the definitions. And it's not just memorizing things like moles over liters or grams over kilograms or moles over kilograms. It really is memorizing moles of what, liters of what. So when you memorize these particular definitions, like molarity, you should memorize that it is the moles of the solute over the liters of solution. Molality is the moles of the solute over the kilograms of solvent. And then the mass percent is the mass of the solute over the mass of the solution. Remembering that the solute is being dissolved the solution is the resulting mixture, and the solvent is the substance that the solute is dissolved into. Usually the solvent is the one that you have more of. Say 10 grams of sodium chloride mixed with 100 grams of water. Water would be the solvent, sodium chloride would be the solution. Alright, so let's look at some problems. Let's take a quick look at a process map, and this might help put some things together. When we're looking at calculating say molarity, we have to determine what the moles of the solute are and what the volume of the solution is. If we're given a mass of a solute, use the molar mass, I can calculate the moles of the solute. If we're given the mass of the solution, I'm going to need the density of the solution to find the volume of the solution. If I'm looking for molality, again, mass of the solute, moles of the solute will give me the moles of the solute. Mass of the solvent, I'm either given the mass of the solvent, I might be given the volume of the solvent, I can get to the mass, that's the volume of the solution. I might have to get to the mass of the solution and the mass of the solute and subtract these two to get the mass of the solvent by itself to determine the molality. Okay, so it's really kind of, if I'm given any one of these pieces of information, how do I get the moles of solute? How do I get the kilograms of solvent? How do I get liters of solution? An important thing to remember, okay, volumes are not additive. You cannot assume this. Look for a problem statement to say that these are. Then you can make the assumption. But unless the problem says to assume that the volumes are additive, you cannot assume that volumes are additive. Okay, so let's go on and apply some of these concepts. So for this problem, we are asked for the molality of a solution made by dissolving 36.5 grams of naphthalene, which is C10H8, in 45 grams of toluene. I'm looking for the molality. Okay, so let's do a given first identify which one of these is likely my solute. Well, it says I'm dissolving the naphthalene in the toluene, so this is going to be my solute. So my solute is 36.5 grams of my C10H8. That means my solvent is the 425 grams of C7H8. What is my unknown? Asking for the molality of the solution. Well, what's the molality? Okay, well, the molality is the moles of solute, which is the C10H8, over kilograms of the solvent, which is the C7H8. Okay, by doing a given and unknown, I'm giving myself a map of where I need to go, what I need to calculate. Do I have enough information to calculate it? Well, oh no, I have to start over. I'm going to pause and write and just rewrite, and then I'll come right back. Okay, so looking for moles of the naphthalene over kilograms of the toluene. I know that I'm given the grams, or the mass of the naphthalene. From a molar mass I can get to moles. I'm going to put that under kilograms of the toluene. Well, I'm given grams of the toluene. I can get to kilograms from that. So I'm going to set those up as a ratio first, and now I'm going to use factor label to get to the moles of naphthalene over kilograms of toluene. Can I calculate the number of moles of naphthalene, the number of grams of naphthalene in 1 mole? Absolutely. If you notice, I put labels. What chemical am I talking about at every step? Right. Can I convert the grams of toluene to kilograms of toluene? Yes. That is just a factor label conversion, unit conversion. Can I calculate the molar mass? Yes. 10 times 1201 plus 8.08 should get 128.18. Now can I put this in the calculator? Yes. And I get a molality of 700,137 molality C10H8 in C7H8. Rounding to sig figs, all of my given have 3, so my answer should be reported as that. Okay. That ends that sample problem.